How does that denominator factor? Yep, I'm going to write it as x minus 2 quantity squared. But what you said was fine. So we have a repeating linear factor. Repeating because the multiplicity is bigger than 1. Linear because the degree of the factor is still 1, right here. The multiplicity dictates the number of fractions. How many fractions do we need? 2. When you have a multiplicity, you count up to that multiplicity, meaning your first denominator will be that factor to the first power. Your second factor will be that factor. Your second denominator will be that factor to the second power. So you count up to that multiplicity. So if you had something to the fourth, then you'll have one denominator as a first, another as a second, another as a third, another as a fourth. So count up to it. Now there is another way of approaching it, but for consistency, I'll just show you this way. Remember, the degree of the numerator is 1 less than the degree of the factor in the denominator. What's the degree of the factor in the denominator of the first fraction? 1. So what's the numerator just going to be? Just the number, a. What's the degree of the factor in the denominator of the second fraction? 1. Remember, degree, factor, degree, multiplicity. Not always the same thing. So what's the numerator going to be? B, just a number. Questions on the setup? What's the next step? Yep, which is x minus 2 quantity squared. Canto, like you are an NBC executive. On the left, you get 5x minus 7. I just want my community back. I'm not asking for much. On the right, notice for the first fraction, only one of the x minus 2's cancel. But for the second fraction, what cancels? All of them. So you're just left with b. Okay, so this is where plugging in numbers starts to fail. You'll see in a second. What number should we plug in for x to make the a term go away? 2. So all the x's become 2's. What do we end up getting for b? 3. Hooray! All right, now what number do we put in for x to make the b term go away? There isn't one. So now that we found all the variables we could find, we found b to be 3. That means we're now going to replace this b with 3. And now what we do is we pick a different number for x as long as it's not 2. You can't pick 2 because that would make the a term go away. So pick a number for x. Huh? Yeah, let's pick 3. So we'll have 5 times 3 minus 7 equals a times 3 minus 2, which is very nice, plus 3. What is 3 minus 2? 1. So on the left, we'll get 8. On the right, we'll get a plus 3. What does a equal to? 5. Hooray! So if you wanted to distribute your a through and do a system, apparently, this will definitely work. Plugging in numbers is fine for this as long as you find what you can and then plug those numbers back in. So there's just a little trick to it. Finish this off, we'll have 5 over x minus 2 plus 3 over x minus 2 quantity squared.